Okay, so problem 3 from homework 8 asks us to sketch a slope field for this equation y prime equals negative x divided by y. So let's go through the procedure of how you would do that. So the first thing that we notice is that whenever x is equal to 0, except for when y is also 0, the slope will be 0, right? Because if we plug in x equals 0, then y prime just equals 0, as long as the denominator is not 0. So that means we can sketch in all along the y-axis where x is equal to 0. The slope is just horizontal, so that means we draw a little line with a slope of 0. Now, away from the origin, when the denominator is 0, that means that the slope is going to be like infinity, so it'll be a vertical line. So we get something like this along the x-axis. But at 0, it's a bit unclear what's going on because we have 0 divided by 0. And so let's leave 0 alone. It's not so clear what's going on there. And the problem doesn't ask us to worry about 0. So let's just leave it at that. Now let's look at these points where neither x nor y is 0. Well, if we're on the line x equals y, so this line here, then we know the slope is negative 1. So we can draw in some slopes of negative 1. And when x is equal to negative y, we see that this fraction is equal to 1. So we can draw in some lines of slope 1 along this path. And then there aren't that many points left for us to check. So at this point, for example, x is 2, y is equal to 1. So that means the slope is negative 2. Down here, the slope turns out to be positive 2. Let's see, here we have x equals 1, y equals negative 2. That means the slope is 1/2. Here it's negative 1/2. And similarly, we can fill in these lines. And it ends up looking something like this. So we can see that for this differential equation, it looks like the solutions are sort of going around in circles. And we'll see when we discuss separation of variables that we can actually solve this equation, and indeed the solutions to this thing look like circles.